You have a session that looks at ways to extract value from all that data that's being acquired through IoT devices. At what point did the main issue shift from data acquisition to data evaluation?
Well, it's a great question. I think, initially there was a lot of work done to sort of transform what we were getting historically through data exhaustion in industrial systems and converting that into something that could be actionable from the machine learning standpoint. And for really the last, I would say, 5-10 years, as computing became more accessible and the opportunity to do data extraction and transform data that was historically for sort of fault detection and diagnosis, turning a light red, taking that and moving to a place where we can use data as a dynamic source to learn from and then ultimately take control of systems. That sort of became, I think, the focal point. So it's not that the notion wasn't there already. We were always doing data collection. Sure. The data was always coming out. But at some point, it was no longer an issue to sort of think about that because there was so much work done in terms of the extraction itself and being able to take it into a new place and have these new use cases.
How should the evaluation be addressed? I mean, should it be baked in from the beginning of the process?
Yeah, absolutely. And one of the things we always spend a lot of time on, in our projects on, is working the problem backwards. So starting with sort of the end-point, what's the goal, what's the outcome that's sort of interest, and then working back into the data strategy. And I think what we're finding is that's not universal, that a lot of times you're sort of tasked with making sense of the data assets that you have, and invariably that sort of leads into a boiling the ocean kind of situation.
So with all of this data coming in from all of these different sensors, how can evaluators separate the important signals from what I'm presuming are a lot of noisy signals?
That's another thing that's that's come a long way as well. And simple outlier detection and trying to fill in sparsity and deal with data quality issues is certainly been a focal point for the industry. But another one that's been enabled as compute power has gone up and cloud resources become available is the opportunity not necessarily to get rid of the noise. And so often what we tend to think of as noise in the data can sometimes unlock either a whole other problem, or it can be the key to a solution. So prematurely sort of deciding what's noise and what signal can sort of lead you down a false path. And by the tools that are available now enable this sort of holistic discovery across very large data sets that might have been difficult to do even 10 years ago.
Interesting. So you don't want the lens to be too specific.
Absolutely not. Those are where the best surprises are sometimes.
Can you point to an example or two of effective value extraction from IoT data? I mean, who's doing good work in this area?
Yeah, there's a bunch of different industries that are taking different approaches on this problem. One that we like a lot, a company that we've partnered with, is Proteus Digital Health here in the Bay Area. They received FDA approval for an ingestible sensor that essentially runs off your stomach acid, and it sends data back to an armband, which then talks to your phone and then does a backhaul up to the internet. So the capability to understand at a very deep level personal quant for healthcare is important. We've also worked with a major athletic equipment manufacturer to do sort of way upstream looking at health and wellness, not necessarily looking at the sick, but trying to think of how to keep people from being sick. And really that is a data problem. It's a prediction problem and helping people change behaviors. And I think that's something that's going to have a definite impact in healthcare.
Is there a step after value extraction? I mean, is it iteration using that information to improve?
I think so, yeah. I mean, value extraction in itself can be, the endpoint of a project, but what we invariably see is that good questions lead to decent answers, but lead to much, much harder questions. And usually the questions that you get on the second, third, and fourth generation of cycling through this process are increasing in value, not decreasing. So it's not necessarily the case that you go and sort of harvest the low-hanging fruit and then make incremental improvement. Sometimes you sort of blow open the problem and you're able to look at things from a completely different perspective and find value chains that weren't even apparent in the initial discovery phase. So that sort of challenge of initial extraction into value extraction, data extraction, value extraction sort of can transform into this cycle where you're continually not only gaining value or extracting value, but also able to redefine your instrumentation process. So going back in, going after new data or creating new instrumentation, I think is sort of the exciting place that we're at right now.
Do you ever expect us to get to a point where value extraction is a non-issue? I mean, the fact that we're here talking about it means that it's an issue. Is it going to be in months or years where it's just something that's part of the process?
Well, I think generally it's more about working from that endpoint backwards again, where you can see an opportunity to fill out a solution based on new data that you might be able to add. So, one of the examples that we talk about is working on large-scale HVAC systems. And HVAC systems in a campus setting can be a huge room full of equipment that needs to be optimized. But there's an opportunity to just go and capture one more data point that might give you the key to sort of unlocking or unraveling the whole problem, and using that data point to then build a solution that immediately you can see gains on. So I think it's not so much that we will move past or we will iterate or evolve past this process of data extraction, value extraction, and on. It's more that now working the other direction, being able to go from a solution or a partway solution, go back and through IoT do data capture in a dynamic and very low cost way that can then sort of redefine the problem. That cycle is expediting very rapidly to the point where we're now almost in real-time feedback loops in every industry, where machines can be informed by their own performance in near time. And that's a fundamentally different way of operating many industries than has been done historically.
You mentioned IoT. What's your take on that term?
Well, it's a funny one, because right now, that we're sitting at an IoT conference and there's a lot of attention towards it. I think it's a label that has to exist because we all need, something to name our meetup groups and that kind of thing. But I think fundamentally, the consensus that I hear from folks is that the notion of calling things of the internet or the Internet of Things will necessarily go away. It's an expiring notion in the same way if you think about electric lights. We don't say electric lights, we say lights.
Right.
We don't say motor cars, we say cars. But there was a time when there were motor cars and there were horse-drawn carriages, so you had to differentiate. And I think right now there are non-internet things and there are internet things, and invariably in time, given the price drops that we're seeing in terms of the equipment and the capability that's enabled through the networked effect, really, it becomes ubiquitous. And at that point, we'll see that drop. Email's another one. We used to say email, and now we're right at that transition point where half the people say email, half the people say mail and imply email. So I think it's one of those things that eventually just goes away because it's just a built-in horizontal capability.
Last question for you. What people or projects are you following these days?
Well, we're really into doing data collection on the front end. We are very focused on analytics and data products. So we take a dependency on hardware for end node or leaf node data capture. We really like Resin here in town. We talked to those guys, being able to program remotely a Raspberry device in the wild, do middle tier separation from your sensors. That's really cool. We really like Helium for their 802.15.4 solution. That's very low cost and very small, low bandwidth, but then also low cost. So we like those guys as well. But the enabling technologies are all over the place. We also like Punch 3 Designs and the light blue beam. That's a great product for hobbyists and people to tinker and get things out quickly in terms of prototypes. So data collection and then the cloud-based systems that are supporting us in analysis are really at the forefront, I think, of what's going on out there.
Great. Thanks for being with us.
Yeah, thanks a lot, Mac.